Hi, I'm Ilka Cassidy, and I'm with Holzraum System, and I'm really excited to show you this project that we were fortunate enough to work on. And we're here today with the entire team. We have the architect, we have the builder, we have the panel designer and CPHC, Passive House Consultant, and even the FIAS Rater. So this is a very exciting project for us, and it really shows you what you can do once you decide to do a passive house. Now let's meet Andrew, the homeowner, for the full tour.
Hi, I'm Andrew, and this is my passive home. I've dubbed it the Art View House, which is a little bit of a double entendre because the initial brief that I did was really based on my love of art, collecting art, and also the fabulous views that this property has. That the views are part of the art. And you'll notice that it's an unusual style for this part of the East Coast. There's really nothing classical about it. It's got a lot of modernist elements, a lot of West Coast contemporary elements, and there's also a lot of Japanese influence. I love Japan and the architecture, and the gardens are not ostensibly Japanese, but have a lot of influences. Some of the cladding materials that we chose, super charred black shoshugiban as a Japanese technique, but the panels up on the second floor are actually mild steel. They're just being allowed to rust. They're not treated in any way, and they'll continue to build the patina over time. When the architects and I were discussing the project and designing it, I asked them, what architectural style is this? And they didn't have a real definitive answer, so I actually coined my own, which I call 21st century modern architecture, because it builds upon the clean lines, the minimalism, the aesthetics of 20th century, mid-century modern, but it's combined with 21st century building science. So we have the clean air, the energy efficiency, everything that sort of goes along with a passive home, but built on a lack of ornamentation, clean lines, interesting, durable materials that hopefully will last my lifetime and beyond. Come on in. So this front entry was very deliberately very open. It looks down into sort of a semi-subterranean art gallery. And this painting here is actually one of the few paintings that we designed around a little bit with this in mind, and sort of the waterfall to bring the eyes over the edge. Probably my favorite architectural feature in the whole house is the staircase, which is also made out of mild steel, the same as the rusty stuff on the outside, except of course this is not getting exposed to the elements, and it's got a little wax on it. And it was roughly inspired by a Bauhaus staircase at the New York Museum of Modern Art, but with a few little twists. But again, very, very minimal ornamentation, just straight lines, let the material speak for itself. And I kind of view it as a sculptural piece of art in and of itself. One of the big debates in the project, just in terms of details, was railings. And one, we had to have real solid railings because we have these look-throughs into the art gallery and the external decks, of course, we needed railings on. But I didn't want to interfere with the views of the art or the outside, so we put a lot of time and energy into coming up with the design of these glass railings that, for the most part, kind of disappear into the space and allow us to see through. And rather than having a lot of partitioned rooms, other than the bedrooms and bathrooms, most of the rest of the space really flows through, and you can see across, you can see out. And the dogs like it because they can sit in a central spot and see me or other guests wherever we're at in the house, which is kind of cool. One of the big discussion points was, do we bring natural gas into the house or not? The street has natural gas, and ultimately we decided not to. Probably the hardest decision that I think a lot of passive home owners have is how to deal with the stove. I'm not necessarily a big gourmet cook, but in my limited experience, dealing with a gas stove is pretty handy. Ultimately, we had to go with an induction stove. It has its positives and negatives. You could boil a pot of water about 3 times as fast as with gas. Super easy to clean. It's safe because you're not going to burn your hand. Don't have to worry about any of that. but it does take some getting used to because it turns off when you take the pan off the stove. So there's a few trade-offs, but that's something I'm getting used to. You can see in this kitchen, dining room, great room, that it's a big giant volume. And I had come from really living in a series of lofts and really high ceiling condominiums on the West Coast in San Francisco and Los Angeles. And so I wanted to recapture that. I get a little claustrophobic now if I'm in lower ceilings, but one of the challenges and advantages in this room is these big windows. And this is a due south exposure. The architects obviously oriented the house so that this access gets a solar gain in the wintertime when the sun is low in the sky. We've got these nice overhangs for the summertime when the sun comes in at a strong angle. And I can tell you in the few months I've lived here between February when I moved in and right now it's the beginning of June, this house is not hard to heat. It really heats itself. The biggest challenge has actually been keeping it cool in the shoulder months in late February and in March because the sun comes in at such an angle that this room can actually heat up to 75, 76 degrees with the heat off. And so sometimes I just actually have to open the door to let some cold air in. That problem's actually resolved itself once we got into May and the sun got steeper in the sky. Easy problem to deal with. One of the sort of funkier little architectural details was I wanted to tie in the second story to this room, and you can see up there that there's a couple little windows that are actually glazed where we can have these little peek look-throughs to the second story hallway. And what I found is my dogs can sit up there and look down at the action going on down here. So kind of fun for them, but it also is a way to kind of connect the different volumes, the major volumes of the architecture. So another consideration when we were building the house was how could I sort of display a lot of art without having to hang it too densely? And an initial discussion was, do we build an auxiliary structure that would be an art barn or art bunker? And ultimately decided to encapsulate it into one structure, one for zoning purposes, but also if we're going to do a passive home, it's easier to do it in one structure than two structures. So we decided to do a subterranean art gallery that does open into grades. So come down the stairs here. I used to collect very intentionally surrealism, and what I found is that in a big space like this, a lot of the mid-century art that's small form kind of gets swallowed up. So this space has kind of pushed me a little bit more into collecting a little bit more contemporary, where the scales get a lot larger. The foundation itself was poured concrete and then polished up, and it's got a big layer of styrofoam on top and air sealant and water sealant and films and fabrics and on top of all the stone and so forth. But I think it kind of came out beautiful. So finally, this is probably my favorite room in the whole house. It's a little speakeasy. We call it the club room. I'm not going to tell you where it is in the house because it has a secret entrance that only members know how to get in. But my landscape architect and the interior designers are a firm called Zen Associates and up in Boston, and they wanted to blend some of the outside materials with the inside. So there's a retaining wall made out of granite outside that's about this thick, and this same granite was cut into small slabs to use as the back bar, and they kind of talk to each other. The steel shelving is the same exact mild steel as the staircase and the exterior cladding. And this is just a fun room to come and sort of modeled after little bars in the Shinjuku district of Tokyo, where you only have 3, 4, 5, 6, 7 seats, and it becomes a real intimate experience. And it's a fun place to kind of escape with friends when they come over. So this is my master bedroom, and one of the things you might notice is it's actually not really that big for a pretty big home. And I decided that I want to dedicate a ton of square footage to this room because other than sleeping in here, I'd rather be out in the other functional rooms. So, this doesn't have a real big footprint. One of the curious things I've noticed in living in a passive home in a small bedroom is at night, I usually sleep with the doors shut. And between 2 dogs and myself, we actually heat this room up a bunch. And so the ERV has got to do its work to to get the heat that we're generating, because it's not escaping through the windows or through the doors. The air tightness, your own person actually is the main source of humidity and heat in a really kind of curious way. And then here in the master bathroom, just worth noting that we really tried to keep the number of materials to a minimum, just not to create too much visual clutter. The bathtub here is actually cast concrete, which reflects the floors and in the house, downstairs and so forth. So now we're up on the second floor, and I very intentionally situated the office up here. This would probably for a lot of people have been the logical space to have a master bedroom, because it probably has the best views of the property, especially in the winter time. You can see out a couple miles and there's really no houses over there. But I figured when I'm sleeping in the master bedroom, it's nighttime and I'm not seeing anything. So I spend a lot of my time behind the desk looking out this way. And so I really wanted the office to have the best daytime views, which is why we're up here, and also have this nice deck that doesn't have any furniture yet. But when the weather is nice, we can go out there and read, talk on the phone, take care of business out there. And again, you can see these crazy heavy doors that slide really nicely, and they lock in, and there's no air getting in or out of that. I really wasn't familiar in any great detail with the concept of a passive home, and so Paul and Kyle did a great job of educating me. And what really sold me on doing it was, I would say, the other benefits: air quality, comfort, lack of bugs, sound pollution, all those types of what I'll call lifestyle and health benefits were kind of what took me over the edge of saying, let's go ahead and do a passive home build.
So high performance was always a part of the project. Comfort, durability, building the best building was always part of the scope. Passive house sort of fell into our laps with that respect. It's something that we were both interested in. When we went panelized, which didn't happen from the start, both Steve and Ilka from Holtzrum were very much into passive house. The builder that ended up being selected, Hansen, was also certified in passive house. And so everybody on the team was very interested in pursuing passive house for this project. The client was also willing, but we wanted to make sure that it made sense. And we were pushing the envelope in many ways to get a really high quality building, and the step further to get it to passive house certification wasn't a huge leap. It was a lot of coordination and a lot of time, but in terms of what we needed to change inside the building, we were almost there.
And the wall construction, roof construction, everything was panelized construction. The basement walls are panelized to reduce the amount of concrete, to reduce the amount of carbon emissions. There's only 2 or 3 pieces of steel in the whole project. That was also limited.
We started with about 10 pieces of steel and tweaked the design here and there, and also tweaked loads with the structural engineer and with Holtzrum to minimize the amount of steel in the project, also reducing cost.
I'm Steve Hessler from Holtzrum System, and I would say my part in our company was sort of converting all the design intent, the architectural design intent, the structural design intent, the mechanical design intent into a model that served a lot of purposes, including panelization, structural panelization, thermal, kind of turning the building that Kyle and Paul created into like sort of a ready to manufacture and install model. And we also delivered all the drawings and then kind of coordinated install with New Energy Works.
We've done a lot of panelized projects in the past, but never to this level before. What's interesting is the client brought panelization to us and said that he was interested. And he was interested because he thought the quality would be higher, and I totally agree with that. And he thought it would make sense from a construction standpoint and a timing standpoint for the project. And so we started exploring and investigating that. The reasons I was really excited about panelization is I thought it would get us more control over the project, and it certainly did. It got us control over what materials were being put into the project, like hemp bat insulation with wood fiberboard insulation outside that. And we were able to really control what was being executed. And having great teammates like Steve and Ilka on the project to help figure out how we're going to execute this project. Without all the modeling, not everything would have worked, and we would have had to figure out a lot of things in the field. The architectural model, even though there was a lot in there, it's sort of inside to outside is a skin, and it knows what's in there, but it doesn't model every single piece like you did. You framed the building in the computer.
So to be able to look at literally every nut and bolt, and how is it going to relate, and are we taking care of it from building science for condensation and also for thermal bridging?
Sure.
You know, those are things that were just great to have all those parts. Hansen was also one of those builders, just like you were an architect, that was able to really embrace and believe in this model, because that's a hard thing to do too. You know, I think they did.
I'm John Hansen. Our company's Hansen Fine Building. This is our second Passive House certified project in the city of Philadelphia. This kind of construction requires a lot of tight coordination between the trades. There was definitely some educating of our subs to make sure that they understood what was required to make this house perform the way it was designed. The good news was we had a very detailed model that was built by Holstrom, and it helped us anticipate issues, clash detection. We were able to understand where the mechanical systems went before we installed. We've done lots of jobs where, you know, mechanical is design build, and you wait till you build the structure, then you figure out where you're going to put everything. In this instance, we had a very detailed model that displayed exactly where all the ducts were going to run and where the potential clashes were, and so that was extremely helpful. And we had an amazing owner also. He wanted a house that performed well. He wasn't necessarily sold on going through the whole certification process. I'm certain he doesn't have any regrets, and you know, we're all going to be very interested to see how the performance models work out. But early indications are that you know, the goal was net positive energy, and we believe that once we get the solar system up and running, that will actually be the case.
So welcome to one of the mechanical rooms. So the mechanical system was quite something on this project. Positive Energy designed the system, and they chose to use ground source heat pumps, and we actually have 3 of them. And then they are connected to air handlers, and those are 5, and they basically supply the heating and cooling for the entire house. So it's basically a water-to-air heating and cooling system, which I had never done before. But it's very, very efficient and worked very well in the energy model.
So with the 3 ground source heat pumps, instead of running refrigerant lines throughout the building, having multiple sources of potential leakage of that refrigerant, the refrigerant is all housed inside these units, factory sealed in a small amount of area. So a tiny amount of refrigerant, and we're running hot and cold water lines throughout the project. It did increase the initial cost of that system. However, there's a lot more flexibility with this system as the parts are interchangeable, and we're expecting a longer life out of this system and more easier to maintain over longer periods of time.
So in terms of ventilation, Positive Energy shows the Zender unit, Q350.
All of the supplies go to all the bedrooms, all the returns come from bathrooms and kitchens, like typical energy recovery ventilation or enthalpy recovery ventilation systems. What we did a little differently for the supply side that Positive Energy worked with us on is the supply for the ERV is directly next to the supply for the heating and cooling, hidden under one register. So it's sort of slightly disguised in terms of having different ports all over the ceiling or something. They're tied together aesthetically.
So we're around Philadelphia, and we're climate zone 4, and it does get really humid in the summer. So the first few projects that we did, we actually didn't really consider dehumidification, because typically houses don't necessarily have that. but we've definitely experienced some higher moisture loads, and we recommend, even if we think we might not need it, we recommend to either install the dehumidification system right away, or at least think about how we would retrofit them afterwards if any issues arise. And in this project, I mean, just because of the artwork, it's just extremely important that the moisture level is perfect all year round. So this project is going to be FIAS 2021 Core certified. And because of the size of the building and the energy usage, we definitely have to supplement with renewable energy to meet the targets for energy consumption. And that's why we need a little bit of solar.
So the idea from the client's perspective is to help with some utility backup. So we do have batteries for this. And so if the power goes out, he's able to do that. We do have a standby generator if the power goes out for much longer, and that can also recharge the batteries if needed. But we basically filled the entire metal bar of the second floor with solar on that roof for a significant size array. And the inverters are over here.
So for the hot water, we chose a Hansen heat pump water heater. What is great about this system as well is that there's no refrigerant, because everything is set up to work with CO2. Do you want to?
Sure. So yeah, not the typical refrigerant. CO2 is what's replacing the refrigerant in this system. It does have an outside unit. We talked about maybe pulling it out of the ground like the rest of the systems. This just seemed to be the more economical and simple way to do it, by having a condenser outside that pulls the heat out of outside and puts it directly in this tank. And this has 3 loops that run through the building to prime all of the hot water throughout the building, and each one of those are controlled with a push button. So when you want to take a shower in one specific zone, you push the button next to the shower, it primes the loop and now heats it. And this is not just passive house, this is becoming code in many places around the country now.
Yeah, and this is actually something that gets tested by the rater as well. So hot water generation is really important because of the energy use, but then also the hot water distribution is very important because we don't want to waste water.
Hi everyone, my name's Emily Smith. I work at Revision Architecture as a sustainability consultant. And for this project, my role was being the FIAS rater. So that means I go around throughout construction at multiple points, verifying that things that were in Ilka's model and in the architecture plans are being implemented successfully into the actual built building. It's really interesting how the certification works because there's FIAS, and that's the certification that we're going for. But it's layers of certifications on top of each other. So some of the requirements are nestled under Energy Star, some of them are nestled under Zero Energy Ready Homes, Indoor Air Plus, and then FIAS is kind of like the icing on the cake, where it has the super stringent blower door and other super stringent protocols above it. But they're all kind of building on top of each other, which does make it challenging sometimes to know, because things like me testing the hot water to make sure that's right, that's nestled into these certifications. And building infiltration is really seeing how leaky is our building, because we really want to separate the inside from the outside. That's like one of Passive House's core principles. So how much air exchange is there within our building, and we want to minimize that. And for FIAS, that threshold is based on the amount of envelope area on our building. So not just square footage, but how tall are our walls, how many ceilings do we have that are open to above to ambient temperatures. And so the threshold for FIAS is 0.06 CFM50 per square foot of envelope area. And so for our building, we needed it to be under 1121 CFM50. A little bit more than 1100. And so for our mid-construction test, I've got to tell you, this is one of my first buildings where I set it up and it passed. We didn't have to go searching for leaks. We didn't have to break out the IR gun to find out what is the huge thing that we're missing. It was a building that I could set it up and it passed, which felt great. But there were some things that we were able to identify as the air barrier in the basement level. I believe it was like a manufacturer's defect where by just looking at the air barrier, you couldn't see anything that was wrong with it. But when you broke out the IR camera and broke out really just the blower door, turning that on and running your hand across it, you could feel these tiny pinpricks of air coming through, which is something that, you know, in your drawings, perfectly flat, to the eye, perfectly normal. But when you go through these verification processes, you're able to identify things that are unexpected and you can remediate them very easily. It was an easy remediation once we found it.
Yeah, and it's great to have the right tools. The IR camera is really, really helpful.
Yeah.
And then the other thing, you can only feel that draft if you really over or under pressurize. So you're really pressurizing or under pressurizing the building. So it's something that typically you would never even feel. How about the hot water? You mentioned that before.
FIAS's requirement is that all of our hot water, our fixtures, need to get hot water to the person in a quick timing because we don't want to be wasting water. And we want to get hot water to where it's needed as quick as possible. And so this building has a recirculation system, which helps a lot. And so a lot of our fixtures here are very close to that recirculation system. But the requirement that FIAS has is to have, if you're filling up a bucket of hot water, the temperature needs to increase by 10 degrees Fahrenheit over 0.6 gallons of water. And so what you do is it's very intense of a test. I take my calibrated 5-gallon bucket or 1-gallon bucket that has a marker for 0.6, set it up, and then turn it on. And so I have a thermometer there measuring to make sure we get a 10-degree rise in temperature and making sure that 10-degree rise happens before we get to 0.6 gallons of water. We checked a lot of things that I just go around taking a bunch of pictures, water fixture, flow rates, toilet flush rates. There's a bunch of things that I need to check up on and put in my own modeling because just like you do the Woofy software, I use a software called REMRate that I submit through my whole other third-party certification processes. Things are always being double-checked and triple-checked throughout this process. I think that doing the blower door test is always a very educational experience. Whenever I'm walking around during site visits, I really like to explain everything. Because even all of the subcontractors, they're interested in what's going on and why we do a blower door test is almost more interesting than the numbers that I have on my page. And being able to walk around and identify leaks and feel where they're happening. I think that we didn't have the door hardware installed at one point, and so you could feel the air leaking through there. And just able for everyone to learn and be educated about this, because really our goal is to have more high performance buildings in general. That's what we would love to see here. And so having that education, getting people excited about it, I feel like that's what the end goal is. And that's what really drives me.
So I'd just like to thank you for spending the time with me and the team and getting a little bit of a glimpse into the process that it took to build this passive home. It really is a team process, from architects to the passive home consultants to the builders and all the quality control and the certification process. And now the dogs and I are fortunate enough to live in a really fantastic space, both visually, comfort-wise. It's really been an amazing process and project, and it's great to be able to call it home.